Good morning, student. Myself, Dr. Govind Sharma, Assistant Professor, Mathematics. Today, with the continuous series of differential equation, again we will discuss about the higher order linear differential equation. Here, we are talking about constant coefficient. Uh, then the dy upon dx is multiplier are constant. Then we have a solution CF plus PI. So we are getting continuous the CI and CF and PA. A learning object is the same because after the this is a basically problem, numerical problem today we are taking. Then the students are able to find out the PI and CF and to understand the method of differential equation. Okay, students. So continue with the problem. We are going to start a very good problem, very important problem with respect to exam. Let's we start. We start a problem. For differential. Solve the differential equation. Here we do d square minus 2d, d square minus 2d plus 1 x sin. And today in lecture we are taking two problems. First is and second is, second we take d square plus 9 sin square. These two problems we are taking in today lecture. Okay, so let's start. This is the form of x and v. This is the form of v square. Okay, pi. So let's start. First question. D square minus 2d plus 1y. Here, this is the coefficient, constant coefficient. So we write auxiliary equation. Yes, here c1 plus c2f is equal. Okay, because the root of the auxiliary equation are real and same. Now pi. Important part is pi. Now okay. Now this is the form of x. So a method we use here, we can write d minus 1 power square x imaginary part की पावर iota. देखिए e की पावर iota x we can write cos x plus iota sin. So here sin x. This is called imaginary part. This is real part. So sin x is imaginary part. So I write here imaginary part of e की power. Now x e की power iota x imaginary. So we can do e की power. Now it converts the problem in e की power alpha x or x. So we can do e की power iota x p plus iota. Okay, imaginary. Continuously write imaginary. Here we can do 1 iota minus 1 plus d. We can write here like that. X imaginary. Or also we can do one thing. Okay, we take iota को बाहर for iota x iota minus 1 का होल स्क्वायर बाहर लिया, ये बन गया 1 प्लस डी अपॉन ये आ जाता है iota x अपॉन iota minus 1 का स्क्वायर 1 प्लस डी iota minus 1 का माइनस 2. ठीक है. Now we can do e की power iota x 1 minus 2d iota minus 1 x imaginary. So e की power iota x iota minus 1 का स्क्वायर x minus 2 अपॉन iota. e का x का वेस्ट करेंगे तो 1 आ जाएगा. So differentiate when x we take inside and dx is equal to 1. Here now this is only we do the solution iota with respect to this. By the segregation we get the result. So major work we have done. Now cos iota x we can write cos x plus iota iota square plus 1 minus 12. And this x iota minus x minus 2. This is called iota square is minus 1, so minus 1 cancel, so this will become cos x plus iota sin x minus 2 iota. So this called x iota Now, now x cos x iota x iota minus x sin x minus x plus 2 cos x cos x minus iota sin x x minus upon 2 iota. So both we multiply with iota. We multiply with iota numerator and denominator. So we get minus iota square. Iota से multiply then iota square become minus iota x sin x minus iota x plus 2 cos x plus sin x minus 2. But this 2 iota square become. Now we separate the terms of iota and without iota. Minus x cos x here plus x minus 2 and this is without iota term plus we can do minus iota taken out x sin x plus x plus 2 cos x upon 2. So this term is real term, this is imaginary term. Here we write here I forget to write here imaginary term imaginary part for imaginary. So imaginary part minus half x sin x plus x plus 2 cos. This is the imaginary part. So, so now the complete solution complete complete solution y is equal to c1 plus c2 x e to power x minus half x sin x plus x plus 2 is called the answer. Okay, the complete solution is c plus ci. Again I repeat this question, very important. पेन चेंज कर लेते हैं. Let's see the students. Here, this part you can do easily here with the same pattern, but in PI, there I change the method. Here we apply XVX form. So sin x and cos x, when there is given sin x cos x, we can change it in imaginary part of Ix and real part of Ix. Okay. So by changing this form, we write XCX. X E iota S power e to power iota EX. So this is the solution exists the imaginary part of e power iota. Okay. Now we take iota plus 1, iota minus 1 outside. So this convert in 1 plus d upon iota minus 1 and take above. So this becomes, so this we multiply inside x item. So this convert in imaginary. Okay? Then we apply imaginary part of this. So for change, so segregate the imaginary and real part, we multiply iota equation. So this segregation x cos x converting minus x sin x because iota square is equal to minus. So iota and iota. This converts minus x cos x iota with x sin x. So iota x sin x iota with x cos x minus x cos x and this minus iota becomes denominator iota square become plus. So this is called the complete solution of square. Now I do take the another one example. Second d square plus 9 y is equal to sin square. I hope above question you can understand very well. E to power iota x is equal to cos x plus iota sin x. So we apply this method. Okay, when the situation is given, qx is given this form. Qx is given in x cos x, x square cos x, x square sin x. We can easily apply the above method. Okay. Above method we can apply and cos x sin x we will change in e to power iota x. So e to power iota x when we change in e to power iota x, then the question becomes e to power alpha x, x or fx. Okay. So here in second example, second example, we see d is equal to plus minus 12. So yeah, we can say auxiliary equation m square plus 9 is equal to 0, m is equal to plus 9. Now, now the solution Vf is equal to a cos Vf plus b because e to power alpha x. We know the Cf is equal to e to power alpha x a cos beta x plus b sin beta x and alpha is equal to 0 here. Okay. Now Right PM. Fine. This is science scale. Science scale X, we can write 1 minus cos square. So we can write 1 by 2. We can write 1 by 9. And this become minus cos 2x upon this. Okay. So here we can write here x to power 0. So 1 by 2, we take 1 by 9 common, 1 upon 9. Okay. So now we will say 1 by 9 1 plus d square by minus 1 here 1 plus cos 2x upon d square plus 9. Okay. Now open this 1 by 9 1 minus. If all terms are 0, so we can only 0. And this is cos 2x. Now 1 by 2, 1 by 9 plus. You can write here cos 2x cos alpha x minus alpha square. So minus 2 cos square is equal to 4 plus 1. So here become 1 by 2, 1 by 9 plus cos 2x here. Okay. So if we apply here 1 by 18 plus cos 2x upon. This is your pi. Now, now the complete solution is y is equal to e cos vx plus b sin 3 plus 1 upon a plus cos x upon. Okay. So this will become your complete solution. Again, I explain this very well. Actually, this type of question are differ from your practices. So I take the example of different questions which are necessary to you have to now we see that d square plus 9 by sin square. Now there is no method we find in special case or general method. We can solve sin square x dx. Okay. So we change this in 1 minus cos 2x by 2 because we know that this is the formula of trigonometry. This is a trigonometric formula. 1 minus cos 2x upon 2. You can say 1 minus cos 2x is equal to 2 sin square. This is trigonometry. Okay. So we write here this time 2 is the constant, so taken out 1 upon d square plus 9 minus cos 2. Now this is 1. We can easily write here as 0. Okay, x to the power 0. So we take this type, we taken out 9 and convert it 1 plus d square upon 9 and invert. So this becomes 1 plus 1 minus 0 all terms d. D square, the differentiation of constant value is 0. Okay, so this becomes 0 and this is cos 2x plus d square plus 9. Okay, this is the important part. You have to understand this very well. Now, cos 2x upon d square plus 9. Here, we can see 1 by 2, 1 by 9 plus cos 2x upon here, we put minus alpha square. Minus alpha square. Here we put d square minus alpha is 4. So this is become. Now this is the pi of a differential equation. So this is the complete solution. Okay, students. Now you have some practice on one basis that d square 2d plus 1 y is equal to cos square. You should try on this. Similarly, d square plus 2d plus 1 x square fine. These two questions you have to try on one basis. After I think after the today lecture, you are capable to do this type of question. You understand that when x is multiplied with b, and what step you have to take. You change the position, you change the method, you change the sin x cos x in the form of e to the power I type. So today we have completed the constant coefficient method for PF in linear differential equation of fire. This is sufficient for us to understand and solve. We can solve all the question by with the help of this. Now, here I want to introduce one more topic. Here, differential equation with variable coefficient. Variable coefficient means क्या है? When like this equation x d2y dx के to x plus 1 dy dx plus xy is equal to 0. And you observe this equation, all the terms of dy upon dx multiply with x. X is the variable. So if the dy derivative is multiplied or with the x square x, yeah, x term, so we call the coefficient is variable. Okay. So in next lecture we are going to start. This is a very important. We have some method to find the variable coefficient to solve the variable coefficient differential equation. Students, now the time of use. So true and false. dfx means the integration of f. The statement is given to us and d. D means what is the mean of d? First, d means d upon dx and d upon dx. You all know very well d upon dx is the differentiation, not integration. Okay, if here I apply 1 upon d, then it will become integration. So here dfx is all differentiation. The wrong statement, this is the first one is wrong statement. To x is equal to x. When general method applied to find pi, a qx is equal to x, then we apply which method? When this is the special case of x to the power n. So we can easily apply special case method and 1 upon d minus 1 to be taken above. It expand the series of form of d and d means the differentiation of x until x to the power m, m the degree of x. So we do the differentiate, we expand till n. So this is I think false because qx is equal to x is can we apply special pi of set to x when fd is linear. Fd means linear means yeah. What is the mean of linear? So here I can show one thing. Show you one thing. Again I take you linear means linear means the function is linear in the sense this may be fd is equal to d minus alpha or d plus. Okay, so the pi is equal to 1 upon d minus alpha sec 2. So here 2 alpha is equal to 2. So we take linear to become 1 d minus 2 And now this is very simple for you to find the solution of this by the journal method. This question I already told, I already taught you that many times. I guide many times that track AX, track 2AX, and AX, track and 2 is a very important part of PA. Okay, so you have to continue practice of this question in any form. This will be asked you in exam. Now, again for the quiz. PI of PI of e की power 3x. Hmm. When we put the value of d minus 3 alpha is equal to 3, then it convert in infinity. Because we know e की power alpha x upon d minus alpha. When put alpha is equal to alpha, then it convert in infinity. So this is not possible. Now we take the another case. We multiply above x and differentiate. So this is the part. 0 is not an answer. Pi of exponential is 0. Not this is not possible because when this case is found, we have multiply with x and differentiate f del t, and then we apply d is equal to l. Okay, so I hope you will understand and do solve this question. Find the pi of this d minus 1, same 1 upon d minus 2. When put d is equal to 2, it becomes 0. So we multiply above x and differentiate the 1. So your pi is become x. Okay? Okay, become root of equation are same and real, then say y is equal to c1 plus c2x e to power. I hope students this is the sufficient material for you and you can understand all the lecture of differential equation. Now we turn the topic and come to the variable coefficient. Okay, so I hope you have taken this is very interesting lecture. All the best for your examination. Thank you very much.